Welcome back.
Yay.
Our next lesson is on solving percent problems. So go ahead and get your title page set up. Get your title up top. Your learning standard, it's been the same one the whole unit, 6RP3. And then our I can statement. I can use multiple strategies for solving a percent problem.
Hey, so here we go. When we're diagramming these types of problems, you've got three parts. There are always three parts to a percent problem. First, we have the part. So that is a piece of the whole that we'll find out at the end. And the part is then some percent of a whole. There's our percent. And then they give us the whole here, and that's of something. So 24 is 75% of that whole, which is 32.
All right, so those are our three pieces, or three parts. There are a couple different strategies for solving a percent problem. One is to use our double number line, what we worked on last night. So go ahead and jot down this problem along with the double number line, and then let's get started on the problem. It said country music makes up 75% of Landon's music library. If he has 90 country music songs, so country music, 75% was country music, how many total songs does he have? So just like in our video last night, start with our percent, 75%. What do I need to count by to get from 0 to 100, but making sure I land on 75? Hopefully, counting by 25s came to mind. So I can do 25%, 50%, and 75%. And then my next step is my 100. It tells me that 90 country songs is equal to that 75% of his country music. So I know that 75 is 90 songs. We want to know what's his total. So think through our steps from last night. 90 is our third stop along the way. So it was 3 times some number got us to 90. So let's work backwards. 90 divided by 3, because it's my 1, 2, third stop, means I must have been counting by 30 at each place. So my first was 30, then my 60, 90, just what I wanted, and that means my last stop is 120. So 100%, all of his songs, is equal to 120 total songs. So using a double number line is one way to solve one of these problems.
Landon is not a DJ.
Apparently not. I thought 120 is pretty low.
So another way that we can solve percent problems is using a percent proportion. And this is going back to what we did in Unit 2, working with proportions. So you know a proportion is when we have two fractions that are set equal to each other. In this, though, one of the fractions is going to be made up entirely of percents. So that would be a portion of 100% and then 100%. And that corresponds to a part, and that part is part of a whole.
So make sure you get this whole thing down because it tells you where to put each piece in the problem as we set up the next couple of problems.
Then we have, going back to our second slide, we understand that 15 then is part of our whole in our diagram here. So there's our part. Then 30% is then part of our percentage. We know that's a piece of that 100%. So we set them up across from each other. Then the 30% is over its whole, which is 100%. And that leaves us the whole that we're missing. There's a hole we have to fill. That's so
You
terrible.
had to go for the joke.
As I know I have a relationship between 15 and 30. So I know that 30 is twice of 15, or half of 30 is 15. That's what I want to say. So then we would just divide 30 by 2. And then I would do the similar thing to my denominators that I did to my numerators, divide 100 by 2, leaving me as a whole of 50. So 30% of 50 is 15.
All right, next one. 225 is 75% of what number? So again, 225, that's part of my number. So that's going to go on top. 75%. Well, that percent sign kind of gives it away. That's our percent in the problem. And percent always goes over 100. So again, similar to the last couple of problems, we're trying to find that total, that whole amount. So think about, how do I get from a 75 to a 225? Might have to do a little bit of thinking, But hopefully you notice that if I multiply times 3, 75 becomes 225. Since they're equivalent fractions, they're equal to each other. We do the same thing to the denominator, just like Mr. Romanovich did in his problem. 100 times 3 means the whole, that missing number, is 300 total. All right, one last one.
Oh, here we
Take it
go.
away.
We've got the English language here now. So in our first year of ownership, the new car lost 20% of its value. Get used to it. If a car loses $4,200 of value in the first year, how much did the car originally cost? So if we start kind of diagramming this, we know that I would start with my percentages. So I know it can lose 20%, so that's my part. And then I know my whole is always going to be 100%. And checking to see, we want to know how much it originally cost. So that would be a total. So we need to know the whole. That's our missing piece. And we know that it lost $4,200. So if you're really up to speed on your 20s, or if you do some mental math and just kind of did 20 or 2 into 420, what you might see is that would be 210. There are 210 20s in 4,200. Or what you could do is you could use the powers of your proportions to see that 20 times 5 would be 500. And if you're operating the same on the left side of that proportion, 4,200 times 5 would then be 21,000, Mr. McKenzie?
I'm pretty sure that's what we figured out.
There we go. And that would be the original cost of the car.
All right. Hope that made sense. We'll do some practice together tomorrow in class.